Hi, I'm Herschel George, one of the watershed specialists with the Kansas Center for Agricultural Resources and the Environment. This video will provide you some of our recommendations, tips, and techniques for installing a solar livestock water pumping system. Solar pumping systems are adapted to many situations, both as permanent fixed systems and as short-term temporary systems such as you would use for livestock grazing cover crops or crop residues and stubble. When we think about solar water pumping systems, we often think of systems like this, with a well, a pump, a permanent installation of the solar panels, and then nearby having a large stock tank, and like this system, having a large water storage tank to take care of those periods of inclement weather or cloudy weather. Or like this system that was just recently installed, you can easily see the solar panel installation, the well, and there's a line going to a hydrant nearby that will supply the tank. But solar livestock water pumping systems can also be movable, as you can see in this system. This is a portable demonstration unit that I have for demonstrating solar livestock watering. This system not only includes the solar panels, it also includes the pump controller, 100 foot of wire that I use on the pump, and of course you can see the pump there as well. In some places, well water is just not an option. Ponds and wet wells can be used as water sources for these solar systems. In this case, a spare tire acts as the float so we can suspend the pump into the deeper parts of the pond. In this installation, a wet well from the pond is serving as our water source. You can see that this producer is using batteries to provide that 3 days of water storage for the system. I would normally tell you to store water, not electricity, but in this case we had no choice other than using the batteries to be our 3 days worth of storage. Before you decide that you're going to build a solar livestock watering system, I think there's some points you need to look at. One is, what is your proximity to AC power? AC power is much more reliable than a solar pump system. The other thing is, how far are you away from a rural water system or other pressurized systems? The question that always comes in my mind is, what are you going to do in those periods of cloudy weather and inclement weather? It just makes it difficult. Another important point is, how much water do you need to pump on a daily basis for your livestock? Solar systems are much more adapted to smaller operations than they are on large operations. It's much easier to consider pumping 500 gallon a day than it is to pump 5,000 gallon a day. And you will need to plan for some sort of a backup power system. You may not need it more than once a year, but you need to know what you're going to do when you have a tank that is low on water. Are you going to pull out a generator? Do you have an adapter that will work? Are you going to use batteries? You need to have a plan and know what you're going to use as soon as it happens. In the summer months, you may get 6 or more hours of pumping, but when it comes wintertime, days get much shorter and you may be down to only having 4 hours of good pumping time. I feel you need to have enough sunshine that you can see your own shadow before a solar pump will actually do much pumping. Solar pumping systems have 3 main components: the solar panels, the pump, and the pump controller. The solar panels, you want to make sure that you consider the voltage and wattage and what you need. You also need to consider the rack and the mounting that it's going to go on. We'll be talking about 3 kinds of pumps: diaphragm pumps, centrifugal pumps, and helical pumps. And pump controllers, and there's basically 2 or 3 kinds of pump controllers we will discuss. Okay, let's talk about solar panels. On the left, you'll see a monocrystalline solar panel. On the right, a polycrystalline. They are so difficult to tell the difference, but for all practical purposes, they do the same thing. These are both 2 100-watt solar panels, and you would consider these 12-volt solar panels. The only way I can tell the difference is the polycrystalline tend to have a little blue tint in them, where the monocrystalline are black. There is another type of solar panel coming in, and that is the bifacials. And that means that they can actually get a little light coming from the back side as well as the front side. That will probably happen over the next years. We'll probably see more of them used. The primary thing that you will want to do is to read and find the voltages that your panel will work, the amperages, and the wattage that it provides. You can read the label and it will probably tell you. This case it says the one on the left is a 100M, the one on the right is a 100P. I'm sure the left means monocrystalline and the P means polycrystalline. The next line there says that both of them are 100-watt solar panels. The next line is about the voltage, and it says this is the open circuit voltage. That means that if there is no load on this panel, it may give you voltages as high as 21 or 22 or 23 volt. But if you put a load on it, it will go back down to in the area of 12 volts to 15 volts. The other thing that you would want to read off of a label is the amperages. How much current can these panels produce? And both of these, it's in the area of 5 amps that each one of them can carry. Solar panels often come in units of 100-watt panels, 200-watt panels, maybe even 400-watt panels, but they're getting awful large. You'll need additional help to move those. The other thing is voltages. We typically think of solar panels come in 12-volt or 24-volt systems. Yeah, there's some that are even 48-volt, and some will go as high as 80 and 90 volt, but they're wired for special purposes. When I'm looking at a livestock producer's solar water installation, I often look at his panels so that I can see what his voltage is, what he's working with, how many amps he's trying to work with. In this case, both of them are 200-watt panels. The one on the left, look at that there, the open current voltage is in the area of 21. Here again, that's what we would call a 12-volt system. But notice it has the ability to produce more amps than the 100-watt systems we looked at earlier. The label on the right, here again, 200-watt panel. But notice the open circuit voltage, 45. Goodness, that's quite a bit. That's probably a 24-volt system. The other thing is, notice though, that it does not have that high amperage. It's still in the 5 amp area. This would be a panel that we use on some of the pumps that need higher voltages. Some pump systems need higher voltages. The higher voltage makes you get concerned when you start working with the pump controllers. The pump controllers will tell you how many volts it can handle. And that is when it's talking about open circuit, it is looking to not have, sometimes in the case, 48 volts or something like that. When we're using solar panels for agricultural uses, I think we need to stick to solar panels that have a rigid aluminum frame on them. The aluminum frame is much more helpful in how we mount them, putting them on the racks and such. The interesting thing is that solar panels are much cheaper than they were back at 2000 or 2005. In that period, they were costing about $5 per watt. Today, you can buy solar panels for about $1 a watt. We'll take a few minutes to talk about the rack that systems are mounted on. Yeah, the rack is basically just the framework that the solar panels are attached to. The pictures here are from some of the temporary or easily movable panel setups that I use. Many people have seen me pull this solar panel trailer down the road. I have 2 panels mounted on it. I can pull it down the road at 50 miles an hour. Doesn't provide any problems. You can see it has on it a fuse box that all the power from the panels go directly to the fuse box and then go on to my controller. I mount it on that piece of metal that you see down there below. The rack mounts on a 2-inch pipe. The gimbal fits right over the top of the 2-inch pipe. This panel rack uses aluminum frame and also has a nice adjustment for angle of the sun, so I can change it whenever I need to. This is not my solar panel trailer, but it sure is a nice one. The producer can pull this up near the well, drop his pump down the well, and he has his controller mounted right on it. A pretty complete system. Racks for solar panels are expensive. Relative to the cost of the panel, the rack may be as much, if not more. This rack is especially expensive. The tube on the left and the right of the rack are Freon tubes, and they are designed so that the panel will follow the sun throughout the day and then return to face the east again when the sun comes out in the morning. For temporary sites that are 12-volt pump system sites, I use these mounts that I can put on a single steel post. Here's a little better view of that rack itself. It has simple angle iron frame and a 2-inch pipe that is attached in about a 45-degree angle. The 2-inch pipe will fit over the top of a steel post. Here you can see us using our 100-watt solar panel setup to charge some batteries for an electric fence system that we use when we're grazing cover crops. Very similar to what I would use if I was using a 12-volt pump system. When I need to use a 24-volt system, I use a dual system like this so I can connect 2 solar panels on a similar format as you saw earlier. It is amazing what these 2 steel posts, how stable it keeps the system. Even in a high wind situation, the 2 steel posts do an excellent job. I like to have the angle iron frame on there so that I can attach either my linear current booster or my charge controller to that frame. That way I have everything tucked away so it does not get bumped when I'm moving it from site to site. You will hear us discuss 12 and 24 volt systems. Many of our systems are 24 volt, but there are some systems that are even higher voltages. And you need to understand how to make 12 volt systems into 24 and on up. Primarily, we do it just like we do batteries. To increase the voltage, you put them in series, the positive from one to the negative of the next. When we're making 12 volt panels into 24 volt systems, we do just like we do on batteries. We connect them in series, therefore the positive from one connects to the negative of the next. It's the same system. When you're needing to go up higher voltages, you do similar connecting in series. But let's talk about pumps for a minute. There's 3 basic types of pumps: diaphragm pumps, centrifugal pumps, and helical pumps. We'll talk about all 3 of them here in a little bit, and a little bit about what their strengths and weaknesses are. If you don't have real clean water, you do not want to consider the helical pumps. But before we get into the difference in pumps, there are 2 basic types of pumps: the standard brush type pump that we've used for years, and the new brushless pumps that are coming out. The brush pumps are much cheaper and simpler. The brushless motors, however, have a little built-in circuit board in the motor itself that replaces the armature and the brushes, and normally are going to last longer with less maintenance. The reason for that is they have less friction inside, none of the brushes rubbing or anything, and supposedly higher efficiencies. Diaphragm pumps are a pretty rugged type of pump. They are a positive displacement pump, which means they can push pretty good heights even when the pump is not running full power. They operate similar to the pump that's on your four-wheeler sprayer with the diaphragms in them. They are simple. These are a common brush type motor. It doesn't hurt them when they run dry, at least not for short periods of time. This one has the ability of pushing a head of water 65, 75, 80 feet tall. Some of them will go up 270 feet. You know, that takes 100 pounds of pressure to do that. They do not need perfectly clean water. They can use pond water, but when you're using them in ponds for an extended period of time, the moss will form on the screens and will cause them to run dry. The diaphragms in these pumps probably should be changed every 3 or 4 years. They are the main part in the pump that moves. This pump would have 4 diaphragms in it, and it can pump about 3.5 gallons a minute. Some pumps have 5 diaphragms in them and can pump more nearly 5 gallons a minute. This diaphragm pump you can buy online for about $150. This 24-volt pump draws about 5 amps. It can push water ahead of about 230 feet and deliver about 3 gallons a minute. Pretty amazing. For cover crop grazing and other temporary water situations, a 12-volt pump will fit in quite nicely. We can connect them to a 12-volt battery using a solar panel to charge the 12-volt battery. It works quite well. But notice the 12-volt system requires 10 amps to drive this pump. That's what happens when you go from a 24-volt system drawing 5 amps. A 12-volt system will draw 10 amps to do the same amount of work. This is a diaphragm pump that is established with a pressure tank. If you say, I have seen a pump similar to this before, it is very similar to the pump that you would use on your four-wheeler sprayer. This one has 5 diaphragms and is designed for about 5 gallons a minute. This Grundfos pump is an example of a helical pump. Helical pumps use a stainless steel helical rotor inside a rubber stator. These need to have clean water. If your well has sand in it, it will chew up the rotors in them and you will need to replace it. However, the rubber stator is replaceable. That's no problem. These Grundfos pumps are pretty special pump. They can push heads as much as 400 feet. Pretty amazing. The other thing about them is they have the pump controller inside the motor. The motor is in the lower part of the pump there. These pumps can use a wide range of voltages. Anything from about 30 volts up to 300 volt DC, or they can use 90 volt AC up to 240 volt AC. It makes it, when you put a generator on the system, quite easy. You do not need any adapters or anything. Disconnect it from the solar panel system, plug it into the generator, and it will operate. A 900 watt generator will make this pump about maximum, which can be 7, 8, and 9 gallons a minute. A centrifugal pump is not a positive displacement pump. In fact, centrifugal pumps create their pressure by having a rapidly spinning impeller that slings the water to the outside, creating the pressure. If the centrifugal pump is then shut off, that pressure will drop and the water will flow back into the water source. That can be an advantage for producers that are wanting the lines to drain back, for example, in the wintertime. But most often, a centrifugal pump will have a check valve involved. The check valve will prevent that backward flow of water through the pump. Centrifugal pumps can be submersible. In fact, many of them are, where the pump is actually in the body of water, down in the well or in the pond. When that's the case, you do not have to worry about the prime because it is submerged. But centrifugal pumps that are not submerged must be primed, and you must have it arranged so that the prime is maintained at all times. Each impeller in a centrifugal pump can only generate 30 to 50 psi. If you need more pressure than 30 and 50 psi, then they use multiple impellers, stack them, as in the irrigation pumps and things of that nature, which need to push water 200 or more feet vertically. This is an example of a 12-volt centrifugal pump. If you say it looks like a little sump pump, that's exactly what it is. It's a 12-volt sump pump. It cannot push high head, meaning it will not push water more than about 15 to 20 feet vertically, but it can move a pretty good volume at a low head, maybe more than the diaphragm pumps can move. The reason you would use a pump of this nature is because it can handle dirtier water than any of the other pump systems. Solar pump systems have lots of connections, but the most important one that needs to be waterproof, is the one that is down in the water near the pump. In this case, you can see the photo on the left has a waterproof connection that is, each of the 3 wires are individually heat shrinked, and then it has a larger heat shrink over the entire group. That makes this a good waterproof connector. On temporary pump setup, I will often use these wire nuts on the right to make those connections. They have inside them dielectric grease. It's full of dielectric grease. If you don't use a waterproof connection, the positive terminal is the one that I have found corrodes most readily, and you need to have that waterproof connection in there or you'll have problems. Let's talk about pump controllers. I think that all pumps need to have some voltage control in front of them. I know you can read on the internet that this solar panel and these pumps can be connected direct, and they can, and they work. But I think for the life of the pump, you need to have better control of the voltage it's receiving. This sun pump system is for a 24 volt. It would control the voltage. It can go no higher than 30 volts. I think that's an important thing for all of our pump systems. This is a pump controller designed for sun pump. It can be used for a range of voltages, 12 volt systems, 24 volt systems, 24 volt battery, whatever. It can also be used with remote switches, an electric switch that controls when the tank is full and when it needs to pump. You can use either a normal closed switch or a normal open switch. This one also has the ability to have a low water sensor used. Otherwise, it can sense when the pump is pumping air and not pumping water. It has a nice set of lights on the side that will tell you what's happening and what's not happening in this controller. Let's talk about another form of pump controller. These linear current boosters do a nice job of keeping the voltage in a narrow range for the pump. I've been rather slow in adapting, but I think they have an important place in our pump systems. Here again, the wiring pattern is simple enough, but you need to understand what it's doing. These can be used on 12 or 24 volt systems with no adjustment. It can tell how much power you're putting to it. The other thing, it can be used on a float switch. Probably the thing that caused me the most reluctance on using linear current boosters is I typically use a normal closed pump switch, and these use normal open. Not a problem if you recognize what it's doing. Probably the other reluctance I had with linear current boosters was being able to read them in the sunlight. When I'm out there in the daytime and trying to figure out, is it working properly, I could not see the lights. Here you can see that top light is lit. But when you get out there in the sunshine, it is very difficult to see. There are linear current boosters that will display more information. This one tells me that the system is a 24-volt system, and it is set up that if it draws less than 1 amp, it's going to shut off. It also says, oh, error. It says it's going to restart in 1 minute. That says it does not have enough current to make the pump operate. Therefore, it's going to shut down for a minute and retest to see if there's enough sunshine, enough energy to make it work. On the right, you can see when it's operating properly, it says 24-volt system, still the 1 amp cutoff, and says that it is providing 23.9 volts to the pump, and the pump is drawing 2.7 amps. It's nice to know that kind of information. If you're using batteries in your system, you'll most likely need to have a charge controller. These charge controllers automatically know if you got 12 or 24 volt systems. This one says that it is holding this battery at 13.4 volts. They do a nice job. I think the top end on this one is 14.4 volts, and it won't let it go any higher. I like to mount my charge controllers right on the back side of the panels, right on the frame. That way I can have my connections all made, and when I get to the field, connect the battery wire from the charge controller to the battery. It will automatically give me a reading of the battery. And at that point, I can then connect the solar panel to the charge controller. You do not want to leave the solar panel connected to the charge controller without having a battery in line. The battery needs to have at least about 10 volts in it for the charge controller to recognize it and to then start charging it more. Here's a different charge controller. You can adjust what voltage you want your maximum charge on your battery. It's not difficult. Charge controllers cost about 25 bucks. Often you can get them shipped with the solar panels. Here again, I like to attach that controller right to the frame, right to the rack, in a way that it is tucked up and away so it doesn't get bumped and knocked around when I am moving it from site to site. Most 24-volt systems will go directly from the panel to a switch directly to the pump controller, and from the pump controller then it comes back to the pump. The remote level switches will hook in separately. They do not hook into the direct power lines. When you're hooking up with the charge control systems, it goes from the solar panel to the charge controller, then to the battery. And a lot of the charge controllers like to then send the charge from the battery to the pump. Like I said, most 24-volt systems will have the solar panel feeding the pump controller, and the pump controller then sending the charge to the pump. The level sensors that are down in the well and the level sensors up into the stock tank all go back to the controller. Those switches are important. On the left is an example of a Grundfos switch. On the right is an example of just a standard breaker box. You open the lid and it's just like your AC breaker box. It's got fuses or breakers in it, and it has an on-off switch. The simplest of switches for float level is the tethered float. It tells the controller when the tank needs water or when it is full. The float moves a small ball inside the tethered float. When it is hanging in the down position, it says it needs water. And then when it raises, that ball moves away and the float says it's full. That would be a normal closed switch. Another type of float that a lot of solar producers like to use is this float that uses a switch that looks similar to a pressure switch. It has a lever that flips up when it is full and drops down when it needs water. These have nice adjustments in them, can adjust for most any depth of tank. Let's take a few minutes to actually look at us installing a pump. We have all of our equipment out here. We have the solar panels. We have the rack that's all disassembled. We have the drop pipe, the Grundfos pump that's in my hand, and there's also the pipe that we will put the rack on when we get it all put together. This pump uses an 1.25" discharge. Most drop pipes are made out of HDPE pipe, the rolled black plastic pipe. So we're attaching a barb fitting to secure the pipe to the pump. Okay, we're rolling out the pump wire here. All pumps need to have a wire that is large enough in diameter so we do not have a lot of voltage drop between the controller and the pump. Number 10 wire seems to be a standard to be used on solar systems. In addition to the pump wire going down the well, we also have the HDPE pipe that will be going down there. We're measuring that here, and we have the yellow cord that is going down there that will be used to secure the pump. The load of the pump should be carried on the yellow cord, not on the pump wire or the drop pipe. Now that we have everything together and dropped down in the well, we're trying to attach everything to the pitless adapter. Here you can see a pitless adapter. The drop pipe is attached to the bottom end of that vertical opening on the left. The pitless adapter allows us to separate the pump and the drop pipe from the horizontal service line that goes to the well. That rubber ring will be in the sidewall of the casing, about 3 feet below the surface. In this case, we're attaching the conduit that goes to the well through the sidewall of the casing, underground, horizontally, and then back up the solar panel mounting pole. And now we have to get the rack put together with the solar panels mounted on it on the mounting pole. And it's best if you can put all of the connections under the panel where it's protected from the weather and in boxes so that it reduces the amount of corrosion that might happen in the system. And sure enough, it all does work. The solar panels, the well, and the pipe going back to serve the livestock tank.